Hello everyone. Today we shall discuss about rotational symmetry. What do you say when the hands of a clock go around? You say that they rotate. The hands of a clock rotate in only one direction about a fixed point, the center of the clock face. Rotation, like movement of the hands of a clock, is called a clockwise rotation. Otherwise, it is said to be anti-clockwise. What can you say about the rotation of the blades of a ceiling fan? Do they rotate clockwise or anti-clockwise, or do they rotate both ways? If we spin the wheel of a bicycle, it rotates. It can rotate in either way, both clockwise and anti-clockwise. Give three examples each for clockwise rotation and anti-clockwise rotation. When an object rotates, its shape and size do not change. The rotation turns an object about a fixed point. The fixed point is the center of rotation. What is the center of rotation of a hands of a clock? Think about it. The angle of turning during rotation is called angle of rotation. A full turn, means a rotation of 360 degree. What is the degree measure of the angle of rotation for half turn? A quarter turn. A half turn means rotation by 180 degree. A quarter turn is rotation by 90 degree. When it is 12 o'clock, the hands of a clock are together. By 3 o'clock, the minute hand would have made 3 complete turns, but the hour hand would have made only a quarter turn. What can you say about their positions at 6 o'clock? Have you ever made a paper windmill? The paper windmill in the picture looks symmetrical. You see, this is symmetrical, but you do not find any line of symmetry. No folding can help you to have coincident halves. However, if you rotate it by 90 degree about a fixed point, the windmill will look exactly the same. You see this one. We say the windmill has a rotational symmetry. In a full turn, there are precisely 4 positions on rotation through the angles of 90 degree, 180 degree, 270 degree, 360 degree when the windmill looks exactly the same. Because of this, we say it has a rotational symmetry of order 4. Here is one more example for rotational symmetry. Consider a square with P as one of its corners. Let us perform quarter turns about the center of the square marked X. In figure 14.31 is the initial position. Rotation by 90 degree about the center leads to figure 14.132. Note the position of P now. Rotate again through 90 degree and you get 14.133. In this way, when you complete 4 quarter turns, the square reaches its original position. It now looks the same in figure 14.131. It can be seen with the help of the positions taken by P. Thus, the square has a rotational symmetry of order 4 about its center. Observe that in this case, the center of rotation is the center of the square. The angle of rotation is 90 degree. The direction of rotation is clockwise. The order of rotational symmetry is 4. Can you tell the order of rotational symmetry for an equilateral triangle? How many positions are there at which the triangle looks exactly the same when rotated about its center by 180 degree? Which of the following, figure 14.1415, have rotational symmetry about the marked point? Do this. Draw two identical parallels, one ABCD on a piece of paper and the other on A', B', C', D' on a transparent sheet. Mark the points of intersection of their diagonals O and O' respectively. Place the parallelogram such that A lies on A, B' lies on B, and so on. O' then falls on O. Stick a pin into shapes at the point O. Now turn the transparent shape in the clockwise direction. How many times do the shapes coincide in one full round? What is the center? What is the order of rotational symmetry? The point where we have the pin is the center rotation. It is the intersecting point of the diagonals in this case. Every object has a rotational symmetry of order 1 if it occupies same position after a rotation of 360 degree. There is one complete revolution. Such cases have no interest for us. We have around U many shapes which possess rotational symmetry. For example, when you slice certain fruits, the cross section are shapes with rotational symmetry. This might surprise you when you notice them, all these things. Then there are many road signs that exhibit rotational symmetry. Next time when you along a busy road, try to identify such road signs and find about the order of rotational symmetry. Think of some more examples for rotational symmetry. Discuss in each case the center of rotation, the angle of rotation, the direction in which the rotation is affected, and the order of rotational symmetry. Here give the order of rotational symmetry of the given figures about the point marked X. Right? Now we shall discuss about the various exercises. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.